Hi guys, welcome back. In this lesson, we're going to be moving on now and talking about separation techniques. Separation is a biggie in chemistry. A lot of it is about separating one substance from another, and a number of methods we used to do that. You can see it right there. So we've got filtration, you've got crystallization, distillation, chromatography, and use for a magnet. So what I've done with this, and of course I'm working from page 15 to 23 of the book as well, so you can follow along there. Quite a few pages there, but it's also quite a lot of material to get through. So we're probably going to split this into a couple of sections. So we'll be starting off talking about filtration and crystallization, I think. And then distillation and chromatography will be in, I think, two separate videos. Chromatography will definitely stand by itself, I think, because there's quite a lot there to discuss. The magnet is, well, that'll be, I think, filtered in around here and there, I think, because the magnet's kind of there. It's been mentioned, but there's no big thing on it. So we'll get to that. So anyway, what I'm going to do while I've got you is we're going to kick off talking about crystallization right here. So crystallization is a biggie in chemistry. It's something that occurs quite a lot and in tandem with filtration. So crystallization, what you're doing literally is you've taken some solute and you've put it into a solvent. Let's say, pick on our friend the salt, chuck it into some water, and then you give it a bit of a stir and it dissolves in. Now, it hasn't gone to form a compound with water, it's just literally formed a solution. It's dissociated into the water, and you've got sodium and chloride ions floating about. What are ions? We'll discuss that later in the course. And we might like to get the salt back. So a way of getting the salt back might be to put it into a crucible like this. There we are, I've already arrowed it for you. And then we put on a Bunsen flame like so. So that's a Bunsen flame. And that is cheaper, neater than it is on paper. So anyway, what we're doing is we're putting heat into this to evaporate off the water. And as we drive the water off, the concentration of the salt is starting to get thicker and thicker. And then you're starting to see more and more of the salt there, as has been pretty much sort of described here, I think. So as we gently boil the water away, the salt becomes more concentrated and more crystals form from the flame. In any case, that's about a time when we'll maybe turn the Bunsen flame off and then put the crucible away to cool down somewhere. And then once it's cooled down, we'll then proceed to filter it off. So filtration then, here's a typical filtration setup. Very basic one. There are other fancy ways of filtering, which are a bit beyond the scope of this video, but stick with chemistry and you will meet it. So what you've got is a standard beaker. There we go, beaker. Not going to label the whole lot, I'm sure you get it by now. And there's the some of the stuff that's poured through. This is a diagram by Taylor Scott, by the way. Fantastic young lady's been helping us out. Here is our funnel, so we put a funnel over the beaker as well. Into the funnel obviously goes in filter paper, which is what this sandpapered coloured stuff is. There we are, that's your filter paper. And then we throw in our residue, which is that stuff. And what we do is we'll probably get a spatula and just sort of scoop it in. And then the water will drip out and drip away, leaving us with the residue in the filter paper, aka the salt. And then all we have to do is to take the filter paper after, gently uncone it and lie it down somewhere to dry off. And if applicable, we'd maybe weigh it. So we might even know what the original weight of the filter paper was, so we could then weigh the filter paper with the salt, get the rest of the salt. So that is pretty much what it is. And this here's the process if you want to have a go. This is this is from the book discussed. The page is, I'd have to put that somewhere. I don't have the book with me to hand actually. But anyway, it is in a book in that page range I gave you. So essentially what this is doing is it's taking rock salt and crushing it with a mortar and pestle. That's the kind of thing used to crush herbs in the olden days. They usually made of granite. Anyway, so you crush it in there. Then what you do is you put the crushed remains into water, into a beaker, give it a good stir with a glass rod, and then once you've done that, you can then give it a good filter to remove the residue that won't dissolve. And then to get the salt, to isolate the salt, all you got to do is use your evaporation basin again to put it back into there, put your Bunsen flame back in under that, leave it to boil for a bit for the water to evaporate away. And it's the same process pretty much as we already discussed. You wait until it's boiling away a fair bit and it's getting more concentrated, and then maybe take it off, let it cool down, and then you might want to use your filtration method again there if there's any water left to get the remaining salt. But as you've already done a filtration, you're probably going to be left pretty much with the crystals there anyway. Certainly in chemistry, normally when you're recrystallizing something, you're going to get it. You're just going to have it recrystallizing in your beaker normally, and then you can just put it into a filter, and then you get your crystals back that way too. But that is essentially the process of crystallization and filtration for you. So as I say, please refer to your book. It is in the page range I mentioned earlier on, so it's between page 15 to 23 of your book. And that is crystallization and filtration, ladies and gentlemen, boys and girls. So I'll leave you to consider that now. And in the next lesson, we'll be talking about the delights of chromatography. See you soon. Hi guys, welcome back. We're following now, talking about fractional distillation and its uses. A bit different to simple distillation in that the liquids that we're distilling here have got closer boiling points than in simple distillation, so we need to take steps to make sure that the distillates, what comes off, doesn't get mixed up. So I've got some words here to explain in detail, but I'm going to be talking over and narrating a lot of this. We're also talking about page 20 of your books, and if I forget to make it later, mention it later, there's exercises on page 21 and 22 down below that goes on and discusses but with exercise questions for all of the separation techniques. You can follow that through after. So essentially what have we got here? So we've poured our entire liquid into the flask. In this case we're using a crude oil substitute. That is one place where this is used. It's in separation of crude oils. This is how they distill off crude oil that they've pumped up from the ground, and it contains petrol, oil, diesel, all sorts, bitumen, and they've got to distill it from a mixture like that. So it works as a mixture will contain different liquids with different boiling points, and even if they're together, close together, this technique allows for easier separation. So as you heat the mixture, the temperature rises, so it's always going to be hotter below, so it's always going to be hotter down here. That's important to remember. I don't know why this does that. It's going to be hotter here and it's going to be cooler here. There we are. So the liquid with a lower boiling point will come off first with the higher boiling points condensing against the glass rods, which then drip back down. And once the temperature reaches the temperature of the liquid dropping back down, then that liquid will boil and come off the same as with the others. So what does all that mean? Well, I've got three liquids here. I will say, disclaimer, that doesn't necessarily marry up to any particular component in crude oil. I've just picked on these for an example. So we're starting to boil this. We've got a Bunsen flame working overtime down there, and it is applying heat to this mixture here, and boiling is beginning to bubble, and we're starting to get evaporation happening, and some of the components are starting to slowly but surely vaporize and start rising up the column. So what we've got in here is a series of glass rods, or in some cases they can be glass beads. So what's happening is these liquids that have got a lower, a slightly higher boiling point are starting to condense back against these beads and come back down. Because while the temperature might be high enough for them here to evaporate, it isn't further up. So what that means is you've got all these liquids here, A, B and C, all boiling away merrily here, and obviously A's got the slightly lower boiling point at 75 degrees C. So A, let's give A the colour of red, shall we say. So A is going to start working its way up out of the column. And for a time, A will also condense back down a few times because the temperature will not be high enough further up for it to remain a gas. It will come back down. But when you get the point here where that temperature there reaches 75 degrees C, that means it's now hot enough. It's going to be hotter than that down here, which is why these will still be having a go. But what it means is, well, it's hot enough for these. It's only hot for let me rephrase that. When it's hot enough for B and C to also have a go at coming up the column, it is only hot enough for substance A to make it all the way to the top of the thermometer and condense out of the system. So that's what we get. That's reached 75 degrees, so it's now hot enough for that one to come up. But as I say, substance B will also give it a go, but only make it that far up. Whereas substance A, it's hot enough for that to continue rising until it comes out into the condenser. So the other subsequent liquids will be condensing back down into the glass rods, and in some cases will simply drip back into the substance there, which has been boiled. So once all the substance A's then come off, the temperature of the thermometer will rise again until it then reaches the temperature at which substance B can come off, which is 100 degrees C, say. Right. I'm not hinting that that's water, by the way, but any liquid with that temperature could then start coming off. So now you've got all of, essentially, A has come off. So now substance B can start working its way up and out. And obviously, if substance C happens to be that blue colour, then substance C will then be having a go at this time. But substance C will also probably only get so far before it condenses and falls back into the flask as well. So the idea is while they are separate, pretty close boiling points, there's enough gap between them such that the glass rods can aid in the condensing of those liquids, so you can still keep them separate from what's coming off at the boiling point. And that's why you've got several receptacles here to receive in all of that. I understand that this isn't for the exam, but some of the industrial distillers have even gone one step further. They know how far up some of the liquids will come for evaporating off, so they've got separate kind of outlets where they can come off at the point where they boil away. I think crude oil manufacturers have that kind of setup. So the lower, the higher boiling point liquids don't necessarily have to come condensing all the way back down. They can literally come off where they condense anyway. Still separate from the lower boiling point liquids that have gone all the way up there, but in that way they're still allowing them off. But that's a bit beyond the scope probably of the GCSE, but worth putting it in here. That's what I like to do with the GCSE. I don't want to overload you with information that you don't need, and I'll always say whether you need that or whether you don't need that. But for the purposes of this, all you need to know is what fractional distillation is and how it works, and how it's able to keep the liquids of slightly differing boiling points separate when evaporating off. So that's pretty much all there is to it. As I say, it's mentioned in page 20 of your books, and as this is now the last video for separation techniques, I will also point out you've got exercises now that cover all the separation techniques we've discussed: crystallization, chromatography, simple distillation and fractional distillation on page 21 and 22 of your books, as are the solutions. And if you've got any questions off of those, please feel free to email me after. Otherwise, I shall see you back when we start talking about the atom. So I'll see you back then.